It's something we don't necessarily want to think about, but we do need to be ready for here in the Northwest. Earthquakes. I'm meteorologist Leah Pizzetti with this special report, When the Earth Shakes. In this multi-part series, our Environment Northwest team is taking a look at multiple subjects, like research being done now to keep us safe and where the risk currently stands. We begin our series with meteorologist Jeremy Legoo, who explains the complex fault lines here in the Northwest.
The Northwest is one of the most seismically active regions in the United States. The threat of an earthquake at any given moment is real in Washington, Oregon, and Idaho. Right below our feet is the meeting place of multiple tectonic plates slowly moving and pushing against each other. The edges of those masses move and break, causing the ground to shake or volcanoes to form. The plates where two of these tectonic plates meet, the Juan de Fuca plate and the North American plate, sits just off the coast and poses the biggest threat for a major earthquake and potential tsunami. It's called the Cascadia Subduction Zone.
And that's why we talk about things like drop, cover, hold on.
Harold Tobin is Washington State seismologist and director of the Pacific Northwest Seismic Network.
Most earthquakes happen in the crust, and a few happen just in the parts of the Earth's mantle that are down these things called subduction zones.
The Cascadia Subduction Zone is a megathrust fault, or the meeting place of two tectonic plates. The Juan de Fuca plate is being forced under the North American plate at a convergent boundary. Friction keeps the plates from moving, but when the force of the plates grows too strong, friction gives way and the plates suddenly move and then stop. The sheer size of the fault means it is capable of producing some of the strongest earthquakes in the world. A magnitude 8 or 9 earthquake off the coast could cause widespread devastation. The movement of those plates is also capable of producing a devastating tsunami along the Pacific coast in Puget Sound. Not all earthquakes occur at the meeting place of tectonic plates. Some, like the Nisqually earthquake in 2001, are caused by the cracking of just one of the plates. As the Juan de Fuca moves underneath the North American plate, the edges become brittle as they are pushed downward. Cracks form in the massive tectonic plate, causing the ground above to shake. While they can still cause devastation, these tend to be weaker than megathrust faults and often don't produce a tsunami threat. The most common fault in the Northwest is the crustal fault. Relatively small cracks forming along the edge of the North American plate, often closer to population centers than their deeper counterparts. Crustal earthquakes are caused by the ground being pushed or pulled apart by the movement of the plate boundary. While those faults don't have the potential to produce a mega earthquake, a magnitude 7 close to a city center still poses a major threat. The two biggest crustal faults are the Seattle Fault and South Whidbey Island Fault. The other sleeping giants of the Northwest are the volcanoes. The final threat of earthquakes in the Northwest comes from volcanic activity. The moving magma beneath the Earth's surface causes changing pressure on the tectonic plates. The changing pressure creates faults or shaking as the ground moves below. Oftentimes we hear of cluster quakes. They signify movement, but not impending eruption. However, long period quakes like what led up to Mount St. Helens are often a sign of something bigger looming. For Environment Northwest, I'm meteorologist Jeremy Legoo.
And when an earthquake strikes, seconds matter. It's a small amount of time that could allow you to receive an emergency alert and find cover. Monitoring equipment around the Northwest is the foundation of the Shake Alert system. I found out how scientists have been working to expand this network.
A small box with a big job.
We're tucked away into a lot of janitors' closets or IT closets at schools and fire stations.
Doug Gibbons, research engineer at the Pacific Northwest Seismic Network, shows off this seismometer hidden in a popular place at the base of the Space Needle.
And this is how fast data is getting back to PNSN and being analyzed for things like earthquake early warning and the Shake Alert project.
This is one of hundreds around the Northwest, part of a growing list helping with faster earthquake alerts.
The shaking from that epicenter is going to hit a station sooner if there's more stations. If we only have a handful of stations, that seismic wave may have to travel dozens of miles before it's detected. Which eliminates several seconds of potential extra warning.
The team has been expanding the network through the last decade. In 2014, there were just 240 seismometers around the Northwest. The USGS set a goal of 600 seismometers needed to properly cover the region, so the team has been expanding the network through the last 10 years. Now, there are nearly 700 stations.
The more we know, the more we're learning, the more data we're collecting, the better that's going to be for us right now and for research down the road.
With Northwest metro areas now fully covered, they're working on expansion beyond. Doug and a team of PNSN scientists are preparing for a journey.
We've got water distributed in this trailer, that trailer.
They're taking their monitoring to new heights.
Yeah, it's a complicated process to get these things up on the side of a volcano, especially a volcano as remote as Glacier Peak.
They're upgrading the single outdated seismometer on the mountain.
What's up there right now is kind of like a black and white TV, and we're putting a 4K TV up there.
This upgrade is years in the making. The scientists hike while a helicopter drops off the equipment at the top. With locating the location of a quake, 3 stations are needed to triangulate which direction the shaking is coming from. The closer the stations are to each other, the more accurate the reading. Volcanoes like Mount St. Helens and Rainier have about 20 stations each, giving detailed information on the exact timing and locations of quakes there. On Glacier Peak, the current closest stations are miles away in Leavenworth and Darrington. The goal here is to add at least a few more seismometer locations to Glacier Peak to better understand this mystery.
And Glacier Peak hasn't had really any locatable seismicity over the past 30 days. And is that because there's no seismicity, or is that because we don't have enough instruments to locate those little earthquakes?
It's not just expansion at the highest elevations, but also the lowest. Right now, 100% of monitoring stations are on land, so scientists are working to add underwater stations off of Oregon's coast in 2026. They'll be plugged in using underwater cables and will further improve that early warning system. Still ahead, the Pacific Northwest is no stranger to earthquakes, and we're now experiencing more of them. Experts weigh in on why and if this is a concern next. So far in our series, When the Earth Shakes, our Environment Northwest team has shown you how fault lines and subduction zones work. We've shown you how experts are working to monitor seismic activity around the region. Now, Environment reporter Cale Williams is taking us inside one of the biggest threats that comes in tandem with earthquakes, tsunamis.
This is footage earlier on when the earthquake has hit.
It's not a matter of if.
You don't know when this is going to happen.
But when?
It's just to get to high ground as soon as you can.
Since January of 1700, tension has been building in the Cascadia subduction zone. That's where tectonic plates under the ocean are slowly sliding under the plate beneath the North American continent. And at some point, it's going to pop.
Then one day it releases all that tension, all that stress is just released. The second plate lifts up, pushes the water out of the way, and that's what creates the tsunami.
That's Dan Cox, professor of coastal and ocean engineering at Oregon State. And he said you don't have to go back to 1700 to see what a tsunami would look like on our coast.
I was actually in Japan after the 2011 tsunami, and I walked through town after town.
On March 11th, the magnitude 9 Tohoku earthquake shook the ground for nearly 6 minutes. Within half an hour, a wall of water washed ashore. Seawalls were easily overcome. Entire villages in the mostly rural areas were washed away. Combined, the earthquake and tsunami killed more than 18,000 people.
And the damage there is probably going to be very similar to what we saw here for that magnitude 9.
If the entire Cascadia subduction zone were to rupture, the ground on the coast is expected to sink by up to 6 feet. The following tsunami could see waves up to 40 feet high, and they could last for hours after the shaking stops. Many low-lying towns would be inundated.
Parts of the coast I worry about is where the people are.
That includes places like Seaside, Neskowin, and Warrenton. The state estimates a tsunami could wipe out areas that are home to some 22,000 people.
Wood frame buildings, residential structures, houses, they really don't fare well. And so the expectation is most of them are going to get washed away.
And estimated deaths from a Cascadia quake range as high as 10,000, with half of those caused by the tsunami.
That would be extremely devastating.
But there are people working on ways to lessen that death toll.
We test extreme conditions, tsunamis and storm surge and big hurricane waves.
Pedro Lamonaco is the director of the O.H. Hinsdale Wave Research Laboratory at Oregon State.
We are really passionate on waves and how that works, and what we call coastal engineering. No?
It's one of the largest and most advanced wave testing facilities in the country, home to a large wave basin and a long flume with a wave generator at the end. When we visited, a team of researchers from Louisiana State and the University of Hawaii were running an experiment on how different types of debris behave in a tsunami.
What kills you in a tsunami is the debris, not the wave itself.
Each of those yellow blocks represents a 40-foot shipping container. And the metal rods, affixed with sensors to record the strength of impact, represent a building along the coast. Once the containers are set up...
Okay, you guys ready for me to run this wave?
Yes, we are.
The wave generator pushes a wall of water down the flume. And the containers, well, they crash right into the building. It may not look impressive, but when you imagine each of those blocks as a 40-foot container, it's easy to see the destruction tsunamis can cause.
Ooh.
And the data collected here has real-world impacts.
Will these have the potential to change building codes on coasts and that type of thing?
It already has done it.
Lamonaco said results from similar experiments conducted last year have already helped change building codes around the country.
To me, it's one of the fastest answers that we have seen. Normally, fundamental research takes years to trickle all the way to the building code. This case was really fast.
Now, if you live on the coast, what happens in a lab on a college campus might not be all that reassuring. For those folks, Dan Cox offered some advice. Start making a plan now.
It takes about 15 to 30 minutes, depending on where we are, till that first wave hits the coast.
That means mapping out an escape route, as well as a plan to reunite with loved ones after a tsunami hits. And while there still is a lot of work to do, Cox said the Pacific Northwest is in a much better place than it was even a decade ago.
When I was first here, there was not even awareness of it. Then it was well, we're aware, but we don't want to do certain things. And now it's all options on the table. Let's try to figure it out. So it's been took a little while, but I think people are really taking it to heart and trying to figure it out.
Cale Williams, KGW News.
That is what it looked like in 2020 when southern Idaho was rattled by the biggest earthquake in almost 40 years. It was originally thought to have happened along the Sawtooth fault line, but now new research shows that may not be the case. Sophia Bliss explains.
It's kind of sad, actually. I felt a little cheated, but my daughter was in the basement of our house about 5 blocks from me. And she called me and she said, "Did you just feel a rumble or something?" And I said, "No."
Dr. Glenn Thackeray.
I'm a professor of geosciences at ISU.
And Dr. Zach Lifton.
I'm a PhD. You don't have to call me doctor, but sometimes goes at the end of my name. Yeah. I am a geologic hazards geologist at the Idaho Geological Survey.
At the center of their research is the 6.5 magnitude quake that rattled much of Idaho.
And then the next thought was just which fault was it? Because that's a question that's on my mind a lot. What are the faults that could impact Idaho?
The epicenter of the earthquake was near Stanley and the Sawtooth Fault, which are known to have seismic activity. That's about 50 miles west of where the largest earthquake ever recorded in Idaho happened back in 1983, the 7.3 magnitude Bora Peak quake. Even though there's seismic activity across this general area, pinpointing which fault line is responsible is difficult. So in March of 2020,
we assumed it was on the Sawtooth Fault because it was located very close to the Sawtooth Fault.
But close isn't confirmation.
Geology is a puzzle, and we don't always have a clear picture of what's happening. You know, we have little pieces and can be pretty ambiguous, and we just do the best we can to put it together with what we've seen.
So researchers headed out to see more. They used the data from aftershocks and LiDAR imaging to see details of the ground surface and pick a site for their study.
And this gray area that stands out a little is the LiDAR. And LiDAR is a really important tool for doing this kind of mapping.
Then they dug a trench across the Sawtooth Fault.
And so by digging a trench across it, we can look at the soil layers that are exposed in that trench and try to decipher what's the history of earthquakes on that fault. How big are they? How often do they happen? Where do they happen?
Dr. Lifton says this was the first trench ever dug on the Sawtooth Fault.
That's kind of the gold standard for understanding a fault's history.
Through their research, they found that the earthquake did not happen on the Sawtooth Fault.
And the fault that we think caused the Stanley earthquake is not quite in the same place.
Which is not what they were expecting to find.
The Sawtooth Fault intersects with a different fault system that we know very little about.
Their research led to the discovery of a new fault line, one they hope to study even more.
So it's a very exciting time up in that area because there's now a lot of attention on these two fault systems.
From a scientific point of view, being able to study these things is exciting. Stanley earthquake was great because it didn't hurt anybody. So in that case, we can learn a lot about that, maybe apply that to other places and maybe try to help people.
For Environment Northwest, I'm meteorologist Sophia Bliss.
Dr. Lifton says researchers are applying for grants to dig more trenches along the fault because they believe there's more information locked in there that may provide more insight about seismic activity of the past and what it could look like in the future. Up next, the threat of a major earthquake is a fact of life living in the Northwest, how some communities are making sure they're prepared for the big one. Next. The Northwest is seeing a spike in earthquake activity from Mount St. Helens earlier this year to more recently Mount Adams in southern Washington. But could these quakes foreshadow something bigger? Savannah Welsh shows us the answers from experts.
When you look at Mount Rainier, what you might not know is that at any given time, there are a number of small earthquakes happening, ranging anywhere from 0.5 to 2.0. Mount Rainier and other volcanoes in the Northwest are seeing more action, and scientists are watching.
The Pacific Northwest, especially west of the Cascades, is a real earthquake hazard zone.
The Northwest, also known as earthquake country. And in the last 9 months, that couldn't be more true. In September, there were 6 earthquakes at Mount Adams, which usually only sees one every couple of years. Mount St. Helens also made headlines with 350 quakes between February and June. And the biggest of 2024, July's 6.4 magnitude earthquake off Vancouver Island. But is all of this normal?
In terms of activity this year, I don't think there's much we've seen that would surprise us.
Jackie Kaplan-Auerbach is a seismologist and professor at Western Washington University in Bellingham. She says that while these earthquakes may be alarming, it's actually business as usual.
Sometimes when activity picks up, again, it's kind of on our minds. We get nervous that maybe this is, a sign that something bigger is coming. We have never, in sort of the history of studying earthquakes, seen patterns that indicate something larger is coming.
But scientists say that doesn't mean we shouldn't be prepared, especially for the big one.
In the future, we expect to have a very large earthquake that comes from offshore. The other side of the coin is that could happen anytime from literally tomorrow, but also 200 years from now.
University of Washington professor and director of the Pacific Northwest Seismic Network, Harold Tobin, says they're bracing for the potential for a 9.0 earthquake from the Cascadia subduction zone. He says that, along with past earthquakes like the 2001 Nisqually earthquake, are reason enough for people to be ready.
I think I kind of give us about a B to B minus for our increased preparedness. We're certainly better prepared than we were at the time of the Nisqually earthquake. Buildings are built better than they were back then. We should be doing a lot more of retrofitting of older buildings and making just all the systems that keep our cities and towns going more resilient.
New technology, especially artificial intelligence, is being used to detect earthquakes. Now, as for public warnings, these are critical. Wireless emergency alerts will be sent directly to your phone to warn those in affected areas. For Environment Northwest, I'm Savannah Welch.
Ask yourself this question. Are you prepared for 2 weeks with no access to power, water, or trips to the grocery store? Erica Zucco finds out how some Northwest communities are preparing for the threat of the big one.
I have about 6 of these canisters ready.
Take a look at Frank Lawler's earthquake kit.
Crank radio. So power off, no problem, you just crank.
Or his binder full of contingency plans, and you may mistake him for someone who's always been prepared.
Oh, not at all.
But it was actually just in recent years he joined up with neighbors to create an emergency hub.
What's great about this is the better you know your neighbors, the better prepared you're going to be to work together to work through a disaster.
More than 50 grassroots groups of neighbors have created similar hubs across the city. One in a number of efforts that came after a wake-up call to the threat of the big one. Many residents remember the Nisqually quake in 2001, shaking much of western Washington, including downtown Seattle.
These will happen someday, and a lot of us have lost what that feels like since 2001, so we want people to know, we want people to be prepared.
Since then, the state has stepped up education efforts, holding drills to help prepare first responders, and using earthquake simulators to show residents how seismic activity would impact a home.
Despite the fact we will have an earthquake someday, and it will be a big and potentially life-changing event, you can survive if you take the action to get prepared now.
For each of us, a big piece of the puzzle is preparing emergency supplies, like Frank's. But for city governments, much of the focus is on finding and fixing vulnerable structures. In Washington, that means projects like retrofitting the Montlake Bridge on 520, upgrades to the West Point treatment plant to prevent sewage spills into Puget Sound, and updating the Green Lake Library. Records show there are still more than 1,000 unreinforced masonry buildings in Seattle, but many are privately owned. When Portland City Council tried to require seismic retrofits, it faced pushback from owners who said they couldn't afford the upgrades. Schools also need upgrades for seismic and tsunami safety, but with budgets tight and voters opposing many levies, some fixes still hang in the balance.
Back, protect your head and neck, please.
But most earthquake researchers say, don't despair, prepare.
Our hub.
Do what you can, like in Frank's neighborhood, Madison Valley.
The neighborhood is going to be what keeps us together.
For Environment Northwest, I'm Erica Zucco.
That wraps up our special When the Earth Shakes. We've put together a list of all of our coverage, plus a list of what you should put in your emergency kit. You can text the word SHAKE to 206-448-4545, and we'll send you a link. We know thinking about these conversations can be challenging, and we always hope earthquakes don't happen, but it's better to be over-prepared and informed than not. Thank you so much for joining us to hear about earthquakes and seismic science happening here in the Northwest. We'll see you next time.